All right, guys, we are going to finish up nonlinear inequalities today. This section is harder than yesterday because we're not talking just plain old parabolas and polynomial curvy things, okay? The graphs we have to look at and the points we have to find are from rational functions. So we got to kind of deal with a bunch of stuff. The warm-up problem I have for today, the first one is off 17b. This is number 9. Part of the homework check is 17b, so it would be really good if you were doing this with us. No, 17b was not yesterday's homework. 15 was yesterday's homework. All right, so number 9 on 17b, how would we start this? You might want to have out your little red card. Yellow card. What did I just say, red? That yellow card. Yep, on the top we can take out an x. We'll have x squared minus 3x plus 2. Does that factor further? Yeah, I think so. X minus 2 and x minus 1, right? To get a positive 2 at the end and negative 3. And the denominator, you can take an x out as well. All right, what do you notice? Anyone disagree or agree? There is a hole at 0, okay? I'm not sure it's at 0, 0, but it is at 0 because there's a common factor here. But before we do that, we would have to state any domain restrictions. So before we simplify anything, x cannot equal 0 or 4. The second thing on the yellow sheet, it says, is to find the hole. Anything that's a common factor that's to the top and the bottom, we'll make a hole. That hole is at x equals 0. And then we have to plug the 0 back in to figure out where the hole is. But you can't plug it into the original because you'll get 0 over 0. To plug it into the reduced one. So I have 0 minus 2 times 0 minus 1 all over 0 minus 4, which would be positive 2 over negative 4. Did I get that right? So negative 1/2. So 0 across, down 1/2 is our hole right there. All right, the third thing on the card is vertical asymptotes. Those are at whatever makes the denominator only equal to 0. So what will make our new reduced denominator equal to 0? Okay. It has to be an equation because it is a line, but it is actually only a boundary on the graph. The fifth thing on this sheet is zeros or x-intercepts. And then y-intercepts. X-intercepts says values that make only the numerator equal to 0. What values will make the numerator equal to 0? 2, 1 is 0. Why not? It's a whole and it already makes both the numerator. That's why it says only the numerator equal to 0. Okay. So 2 and 1, is that the ordered pair 2, 1? No. No. There's an x-intercept at 2, 0 and one at 1, 0. All right. The y-intercept is what we get when we put in a 0, it says. Can I put in a 0? It's got a hole on the y-axis, right? If you put in a 0 to the original one, you get undefined. If you put it into the reduced one, you get negative 1/2. There isn't a y-intercept. There's a hole, though, on the y-axis. All right. Number 7, the degree of the numerator-denominator business. What's going on here? Okay. So it's top-heavy, so we have to do what? Yes, we do. I will tell you that we could use synthetic division on the reduced polynomial, but I think it's good practice for us to do long division. So if I open a new slide here, will you guys read me the, what's going on? Okay, just kidding. Why won't it give me a new slide? All right, it was, okay, so x squared into x cubed multiply by an x. Then the x multiplies by all of this. So I get x cubed minus 4x squared. Then I am subtracting. So I end up with -3 minus -4 plus 4, which will be an x squared. X squared times what will become x squared? Okay, positive 1. X squared minus 4x. Do I need to keep going? Anything down here is going to be remainder, and it says we can ignore the remainder. So what do I have for my end behavior equation? It needs to be an equation, so y equals, yes, y equals x plus 1. So it crosses here at 1, and it's going up 1 and over 1. Thank you. All right, I think I can kind of see the shape that's going to be down here. What do you think? But do you remember what we talked about yesterday? We had one like this. There's a vertical asymptote, so there's going to be another piece to this graph somewhere. All right, I am so prepared today. Look at all these I have typed in for us. All right, the first one is the one we're looking at right now. If I do a zoom 6, this is what I get. Well, I can see a teeny tiny piece of this one up here, right? But maybe I need to go a little bit higher. If I change my Y to like, I'm going to go 25 because I can't see 0. There we go. All right, if I trace, interesting, what happens if I trace 0? Nothing, right? Because that was where the hole was. Okay. It did barely cross at 1 and then went back down at 2. If I trace over to the right just a little bit, I just want to see where this actual... this is at like 512, okay? So it would be over here at 5, but it would be way up at 12 before we had that loop. So I'm just going to draw it up there somewhere. And the rest of it was down here. And it did just kind of cross, and then it went back down. The ones on the quiz will fit on the graph paper. Okay. Any questions about this one? All right, I do have another warm-up because it's on Friday's quiz. How do you write a polynomial with zeros at 3, 4, -5i, and it has to have real coefficients? X minus 3, x minus 4. Well, this is a -5i, so it would be plus 5i. But if there's a -5i, there has to be a positive 5i. So we'd have x minus 5i. Now, are we done? Okay, it says we have to have real coefficients. We can't have these. If we FOIL that together, we have an x minus 3 and x minus 4. What happens back here? This is canceled. We have an x squared minus 25i squared. What's a negative 25i squared become? Can that factor again? That's so many of you got to hear, and then you decided, oh, this must factor x plus 5, x minus 5. If it did, wouldn't there have been zeros at 5 and -5? Yeah. It doesn't factor, that's why it had imaginary solutions. Yes. Yeah. But if that was true, then there would have been up here a 5i and a negative 5i. Or a 5 and a negative 5, no i's. Any questions on that one? I have one more warm-up today. Just warm up crazy. Because this is on Friday's quiz. What can you tell me about this? This is negative 5 to 5. It says in the directions, and I don't know what this scale is going this way. How are we going to write an equation? What do you know right here? Negative 3 is a 0. Does it have any multiplicity? No. So just be multiplicity 1 because it's crossing there. Let me erase the word 0. That's just confusing. All right. At 0, it has multiplicity even. I would just go with 2 because it's bouncing, right? Does everybody see that? Does anybody not have a clue what we're talking about when we say that? It didn't actually cross here. It turned around and went back. So this little shape is like an x minus 0 quantity squared. There's a little parabola shape there, okay? Or just an x squared. All right, and then over here, 1, 2, 3, 4, it's doing a cross. So at positive 4, multiplicity 1. Okay, so we're almost done. We have y equals what? X plus 3. X squared or x minus 0 squared or x plus 0 squared, it doesn't matter. X minus 4. Okay, the only last little part is we have to figure out if there's a stretch. They call it K for some reason on these. You can call it A, it doesn't matter. What are we going to put in to find that? Yep, 140 equals K times 2 plus 3 times 2 squared times 2 minus 4. This is 5 times 4 times a negative 2, which is negative 40. Lovely. So K is going to be 140 over 40, or 14 over negative 4, if I knock off the zeros, which is negative 7/2. Okay, we could graph that in the calculator and make sure it went through those points and looked something like that. But what is one check that's easy? Did it have to be negative? Why did it have to be negative? Why did K have to be negative? Yeah, because usually we had a degree 4 equation here, right? Total of 4 zeros, counting this one as multiplicity 2. So usually it would open up. This one's opening down. So that was, we knew it should come out negative. All right, it's right. I remember when I wrote the question. All right, now we're on 14B. Everybody ready to do notes? Phones away. This is not an easy section, okay? But there's one rule you have to remember when you do these. Okay, let me show you what these are going to look like. This is your homework tonight, starting with number 6, 7, 8, 9, and 10. Okay? Yep. 6, 7, 8, 9, and 10. The idea here is you are going to solve these by first writing the inequality in general form with a single rational expression on the left and 0 on the right. I cannot stress that enough. Okay? You have to make this a single fraction with 0 on the right. or less than or greater than 0. So no matter what it starts with, you want to end up something, an inequality and 0, a single fraction over here. Okay? I was just trying to see if it said that on the top of yours. Okay, so here's an example you don't have. To be able to combine these into a single fraction, what would the common denominator be? X minus 6 times x plus 1. We already have a 0 over here, so we just need to get these combined. Yep, the 4 would multiply by an x plus 1, and the 2 over x plus 1 would have to multiply by an x minus 6. Did I skip too many steps? Okay, so if I distribute on the top, I end up with 4x plus 4 plus 2x minus 6, which combines to become 6x minus 2. Okay, x minus 6 and an x plus 1. All right, you have to today set numerator and denominator equal to 0. You guys have a question? Did I mess something up? Or Nolan? Oh, that should be a 12. Thanks. Which will make this minus 8. Is that better, guys? Thanks. Yeah, because it should match over here. I just didn't check. Thanks. All right. The critical values here will occur at what makes the numerator and denominator 0. We didn't have a numerator or denominator yesterday. Remember, we just had something after we factored like this. And then we graphed it. We said it crossed at 5 and -2, and it was less than 0 in between those values or whatever. Today, we're going to have messy, messy graphs. So we have to know the critical values going into the graph. What are the critical values here? What makes the denominator 0? Okay, so if we were graphing this, it would have a vertical asymptote at -1 and +6, and it would have a 0 at what's 6x minus 8 equals 0? 4/3, which is a positive greater than 1 value, right? Okay, then you're going to pull out your calculator and you're going to graph it. You don't have to do this one. I did it for you if you just want to watch. I did type the original polynomial, 4 over x minus 6 plus 2 over x plus 1. Okay, order of operations says I don't need extra parentheses. Just you could put an extra set here and here, but it won't matter. Okay, we have rewritten this as a combined fraction, but by leaving it in my calculator this way, I'll make sure that it makes sense, that I didn't factor it wrong or something. Let's try a standard window to start. Okay, what did we have for our values? -1, okay? What's it doing out past -1? It's all negative, right? Graph is all negative. So I'm just going to put a couple negative signs out here. Don't matter how many you put. Somebody always asked, is there like a magical number? You put so much? No, I just negative out there. Okay, then we have from -1 until 4/3. What was it doing from -1 until 4/3 here? Well, if I put in a 0, whoops, if I put in a 0, it's positive at the moment, right? If I put in a 1, it's positive. If I go past 4/3, like 4 divided by 3 should come out 0. If I go a little bit past that, then it becomes what? Negative. Okay, so between -1 and 4/3, the value of the function was, the y values were positive. Then out past 4/3, it was negative. Was it negative all the way till 6? Looks like it, right? If I go to 6, it's undefined. If I go to the left, it's definitely negative. If I go to the right, it's up here somewhere. It's positive. Ugh. Yes.
On the test, right?
We found the critical values by setting the top and bottom equal to 0, okay? If you wanted to sketch the actual graph, you could, or you could just tell me, was it positive or negative? Because the answer to the question now is super easy because we want to know where it's greater than 0. So because we did all this work down here, Kayvon, we can now say greater than 0 is in here and over here, right? Now, interval notation, okay? If this was a greater than or equal to, would we have all square brackets? The trick question. If it had been a greater than or equal to, normally we would put all square brackets here and be done. Does anyone know why we couldn't do that on this question? What are the two things it can never equal? 6 and -1. So we would have had to switch this to a parenthesis and this to a parenthesis. Now, the original question didn't have the or equal to, so we're just going to use all parentheses. So I have -1 to 4/3 and 6 to infinity is where it is greater than 0. Does it look up here, guys? From -1 to 4/3, see right there? And from 6 to the right, it stays positive, yes? All right, let's try this. It says, I think this is in your notes. A rational inequality can change signs at its points of discontinuity as well as at its zeros, so you have to set both the numerator and denominator as your critical values. Oh, you have this one done for you too? All right, well, I'm going to skip to this part. Got a common denominator, add them together, I'm to here. What are the critical values? From right there. Anybody? What makes top or bottom equal to 0? Positive 2/3. Positive 4, which is to the right of that. And -1, which is to the left of that. Guys, I won't believe how many people will write 3 numbers on their critical value chart and not put them in order. Okay, you got to have them left to right. Does that make sense? Okay. Then we would graph this. Let's see if I put this one in. It has a 2 over x minus 4, right? Did I put it in here? I think it's this one, isn't it? 2 over x minus 4 plus 1 over x plus 1. Okay, so let me turn that one on and graph it. All right, so what were the critical values? -1, yes? What was it doing before -1? Guys, do you want me to stop putting ones that are already done for you on the notes? Is it because you fall asleep when I'm not making you write it down? I usually put an example that's done for you on there so that if you're absent, at least there's one that's already done. Okay? But everybody's falling asleep here. We're negative until we get to -1, then we're positive. Did we have a value like 2/3 or something on this one? Or 3/2? Okay, somewhere in here it crosses and it becomes negative again until was like 4 a critical value, and then it's positive to the right of that. Okay, so to the left of -1 it was negative. Between -1 and positive 2/3 right in here it was positive. Then it was negative until 4, and then it's positive after. Notice, guys, on both of those examples, it either went plus, minus, or minus, plus. In general, that's the case, but if there's any kind of a bounce, that is not true. So you got to be a little bit careful. All right, the last part of the question is, where is it greater than 0? So where is this greater than 0? Tell me an interval notation. Greater than 0 means positive. Where is it positive? From -1 to 2/3, and then 4 to infinity. Okay? Why did I not need any brackets this time? because it just was greater than, it was not or equal to. If it had been or equal to, the only number I could put a square bracket at would have been the 2/3, okay? Because if the denominator is 0, it can't be. So we would have had a square bracket at 2/3. The rest would be still round. All right. We are moving on to number 5 that you have. Okay, first part is make it compare to 0. So we have x minus 1 over x plus 2 minus 3 is greater than 0. Second thing is it has to be a single fraction. So how can we make the top and bottom of this the same as this? Okay, we've got to multiply an x plus 2 over an x plus 2 so that the common denominator will be x plus 2. Okay. Up top here, I'll have an x minus 1. Be careful what happens back here, though. Negative 3x minus 6. Yeah, we're distributing that as a negative 3. All right. So the top simplifies to what? Negative 2x minus 7 over x plus 2. All right, so we only have 2 critical values this time. What are the 2 critical values? Okay, let's write it down. Negative 2x minus 7 equals 0. Negative 2x equals 7. X equals negative 7/2, okay? Which is negative 3.5, right? And the other one? Negative 2, if we set the denominator 0. Which side is negative 2 on of negative 7/2? Did I do this wrong? Okay, this is like negative 3.5. So negative 2 would be up here. 0 would be up here somewhere, right? Okay. So we're going to graph this. I think I typed it in. Do you see how I typed it in, guys? I just used the original one. X minus 1 over x plus 2, and then I subtracted the 3 over to the other side. Or you can type it in as we just simplified it. You'd need parentheses around the top and parentheses around the bottom. All right, I got this. So what did we have? Negative 3.5. If I go trace negative 3.5 or 7/2, what is it doing before there, to the left of there? It's negative. And then it's positive, right? Where's my slide? So it was negative over here, and then it was positive. What happens at negative 2 on the graph? Actually, at negative 2, it's undefined, right? There's an asymptote here. But then we keep going to the right of it, it's negative, and it stays negative, right? So where is it greater than 0? From negative 7/2 to negative 2, because that's where it's positive. Now, if it had had or equal to, which one could have been a square bracket? The 7/2, but not the negative 2, because it would make the denominator 0, and it could never be 0. All right, number 6. Can you guys try this one? Yeah. Subtract it over, get a common denominator, graph it. Test today, Nelson. Good luck. Interesting. What happens? So I just have a 6 over an x minus 4? So apparently the only place it's going to change sign is at positive 4, right? Okay. I think I did type the original one in. Let's see if it agrees with what we just said. On the sign chart, yep. So I typed x plus 2 over x minus 4, and then I just subtracted 1 over to that side. Is it only changing sign at one place? Yeah. Where that asymptote is at 4, right? Otherwise, the left of it was negative. To the right of 4, it's positive. So it changed sign at 4. It was negative over here and then positive over here. So how do we write, where is it greater than or equal to 0? Okay, do we do this? Because it was or equal to. Even though it was an or equal to, I can't put the 4? I can't put the bracket because, yeah, because back here putting a 4 in would have made that not part of the domain or divide by 0. So it is just a parenthesis, even though it said or equal to. That's wrong. What did I do wrong? What? Because 6 can never equal 0. You could put it on there, but when you looked at the graph and you went out like to 5, it's still positive. It's not changing at 6 or anything. You went out to 6, it's still positive, okay? So if you put it on there, you just have to figure out that it stayed positive all along, but you shouldn't put it on there. Guys, I did this wrong. What did I do wrong? Is this a greater than? No. No, this is a less than or equal to. So we were good until the very end. Then I asked you the wrong question. It should be less than or equal to 0, which would be this side. So it should be negative infinity to 4. But I still can't include the 4. Nobody checked me. Are we better? Okay. Number 7. Well, we got the 0 part. What do we have to do, though? Yeah, get a common denominator to add. So we have 1 over x plus 2 plus 3 over x minus 4. What is the common denominator going to be? X plus 2 and x minus 4. So this one needs to multiply by x minus 4 over x minus 4. And this one needs to multiply by an x plus 2 over an x plus 2. And it is greater than 0 if I ever get that right. Okay, what happens up top? Which simplifies to? Now, we could factor something out of the top, but it really doesn't matter. We just need the critical values. Anybody know what they are? 1/2. Be careful. If I set the top equal to 0, we get 4x equals negative 2 divided by 4. It's negative 1/2, negative 2, and positive 4. What order do those go in from left to right? Okay. So I typed it in as 1 divided by x plus 2 plus 3 divided by x minus 4. When I put it in here, if I put it in correctly, 1 divided by x plus 2 plus 3 divided by x minus 4. Is that the right one? Okay, here's what I get. what were my critical values? -2? Okay, to the left of -2, it's doing what? Well, it's negative. Okay. Then here's -2. Just to the right of -2, it's positive until it gets to -1/2. Then after -1/2, it becomes negative until it gets to, what was our other critical value? 4? Okay, let me do this so we're sure we're getting this. So to the left of -2, it was negative. Between -2 and -1/2 is this piece, so it was positive. From -1/2 until 4 was that piece, it was negative. And out past here, it all stayed positive. Yes? No. No, it can go positive, negative, positive, negative. It actually doesn't have to be an alternating if it had a squared in there somewhere, but it depends if it said or equal to 0, because I'll give you an example in a second, okay? Let's finish this one. We want to know where it's greater than 0. So final answer, where is this mess greater than 0? Nice, we don't have an or equal to worry about, right? So we just have parentheses, -2 to -1/2, together with or to infinity. I think I was nice on the one on the quiz, and I just didn't put an or equal to, so you don't have to worry about brackets and whether it makes the denominator 0, okay? The question asked was, if we had a sign chart that went positive, positive, -3, and it stayed positive over here because there was a bounce, and then we had a 2 and it changed to negative, and then we had a 5 and it changed back to positive, okay? So yes. No, it's on Tuesday's quiz. So the graph might have been doing something like this. Does that make sense? It had a bounce here, okay? Which actually my graph is not a rational function. I should have made it a rational function. I wasn't thinking. But as long as the question said, where is this function greater than 0, you would need this point, Kayvon, because you would have to say it's greater than 0 from -infinity to -3, again from -3 to +2, and again from 5 to infinity. Right, if it's or equal to, then you could have lumped all this together and just said from -infinity to 2, hard bracket, and then 5 to infinity, okay? Answered that question. All right, last one, I think. Yes? So we have 2x plus 1 over 3x minus 1, and we have to add the 1 over to that side so that we compare it to 0. And then we need to make it a single fraction, so we're going to multiply by what? 3x minus 1 over 3x minus 1. 2. Thanks. Someone check me. 3x minus 2, 3x minus 2, 3x minus 2. Do I have it right now? Okay. So up, the denominator is just 3x minus 2. What's the numerator? 2x plus 1 plus 3x minus 2, which simplifies to 5x. Oh, lovely. We have a couple of dandy fractions here to work with, right? Yeah. Our two critical values, if we set this equal to 0, we get 1/5 positive. We set this one equal to 0, we get 2/3 positive. Okay. So 0 would be here. Then what would come next? 1/5 is a critical value, and then 2/3. Whew. What falls between there? Anybody give me a decimal for either of those? And this one is 0.67. So what's something that's in there? 0.25 would be in between there, or 0.5, a half would be in there, right? Just so we can check it when we go to graph it. All right. We might need a tiny little window because we're really concerned about a very small area this time. All right. Is this what I'm supposed to have typed in? 2x plus 1 over 3x minus 2, and then we added a 1 over there. Did I type it right? Because I haven't checked any of these. Okay. In a standard window, this is what's happening. What do we want to know? Where it's... Okay. So it's positive, 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 then negative, then positive, 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 right? So the only place it's negative is positive, negative, positive. We said 0.5, right? I just want to check that 0.5 trace 0.5 is indeed negative, okay? So greater than or equal to 0. Negative infinity to 1/5. And which one can be a bracket? Yes, the 1/5 is a bracket. The 2/3 would make the denominator 0, so it can't be a bracket. So we'd have a parenthesis, bracket. Infinities always get parentheses. Okay? Any questions? So 6 through 10. 6 through 10 on worksheet 15A.